Hello there. We are spies working for a classified and unnamed organization, currently undercover in a classified location. We have uncovered a plot for two villainous spies to collide two cars filled with explosive and destroy the universe.
We know that the two evil organizations are going to collide right on this road, but we need to find the exact place and time it's going to happen. We are going to have to use all of our intelligence agencies all together to discover this information.
You know what that means. It's time for some super cool spy math! Super cool spy math!
In this experiment, we will release the slow car 3 seconds before the fast car, 3 meters apart, to record the car's collision time and position. This way, we'll be able to stop the evil agents from colliding and exploding the area with their explosives. Now it's time for some super spy data time!
Pew pew, pew pew. Sorry guys, just getting some bad guys. Let's get started.
Average speed equals distance over time. First car, or the baby car, traveled the distance in 4.96 seconds. Divided the distance, which is 3 meters, over the time, and found that the velocity is 0.605 meters per second. We found the second car traveled the distance in 13.58 seconds. Found if we divided the distance over the time, we discovered that the velocity is 0.221 meters per second.
The slow car's equation is negative 0.221 quantity x plus 3 because it started 3 seconds before the fast car at a position of positive 3 meters. And the fast car's equation is 0.605x because it's traveling in the positive direction. To find the car's collision point, we first use a position time graph. When we graph the two equations for motion, we find that the cars collide at 5.825 seconds at a position of 1.71 meters. To calculate the collision point, we used algebraic equations to solve for it. The equation for the motion of the slow car is y equals negative 0.221 quantity x plus 3 because of its negative direction starting at 3 seconds before the fast car at a position of positive 3 meters. The equation for the motion of the fast car is y equals 0.605x because of its positive direction at a starting position of 0 meters. To solve, we set the equations equal to each other, eliminating the y. X equals 2.82 seconds. We then plug this x value back into the fast car's equation. Final collision prediction is 2.82 seconds at 1.71 meters. After we finish calculating our prediction, we set up a procedure to test it. We position the two constant velocity cars 3 meters apart and release the slow car in the negative direction 3 seconds before the fast car. They collided at a time of 2.8 seconds and a position of 1.72 meters, only 1 centimeter and 0.2 seconds off from our prediction. We also used a velocity time graph to compare our data. The slow car had a velocity of negative 0.221 meters per second, while the fast car had a velocity of 0.605 meters per second, starting 3 seconds after the slow car. The zero slopes of these lines show that these cars had a constant velocity for the duration of their travel.
Super spies in a super spy location, classified area, trying to stop evil villains from colliding to explosive cars using super cool spy math and physics. Woo! We are spies! Super spies! Super spies!
Even though we were able to stop the evil supervillains from blowing up the universe, it wasn't exact compared to our calculations. This could be because the ground wasn't even, or the car wheels were not exactly straight, or wind. It also was because the stopwatch on the iPhone is not exact. Ways we could fix this is use a more controlled environment and a more exact measuring tool.
Super Spies for Lisa Xavier's AP Physics class.
Yeah.
Trying to calculate two cars' collision.
It's gonna
so
be
that
great.
they don't explode the world. Super Spies. Featuring Candy as